Today we are going to talk about word problems, which are the application of quadratic relations. We start with the first problem. It talks about a quarterback which passes the ball. The equation representing the height of the ball is given here as y equal negative 0.01 x squared plus 0.4 x plus 1. Y is the height of the ball and x is the horizontal distance in meters from where the quarterback shoots the ball. Now, the first question is asking is, what type of graph do you think it is? Is it linear, quadratic, or neither? Without even going through the analysis, you know that the ball is going to have a path like this one, and this represents a quadratic relation. Another way of looking at it is to look at the variable x and the highest exponent it has. The highest exponent is 2, which is shown here, and we said before that when the exponent of independent variable is 2, the highest one, then this represents a quadratic. So the answer to this question is quadratic. Now the second part of the question says, is the graph opening upward or downward? Again, if we look at the graph, we know that the graph follows something like this one. And it is obvious that it opens downward. But if you want to look at the equation, you can see that the leading coefficient is negative 0.01, which is negative, so the graph opens downward. The next question is, does the graph have a maximum or a minimum? If you look at our graph, you can see that the maximum reaches here and then it follows downward. So we can say that this graph has a maximum instead of a minimum. So the answer is maximum. Now the next question, what is the maximum height of the ball? The maximum height of the ball, we need the vertex, the coordinate of the vertex. To find the coordinate of the vertex, this is in standard form, the quadratic relation. And we said previously to find the x-coordinate of the vertex, we have to use the formula minus b over 2a. So we are going to go ahead and use the formula to find the x-coordinate. Now, we know that the x-coordinate of the vertex, x, is negative b over 2a. Negative b is negative 0.4 divided by 2a. The leading coefficient was 0.01. If you simplify this one, you get 20. Since x represents a distance, horizontal distance, so this is 20 meters. Now to find the y-coordinate, we substitute this back in the equation and find y. So we get negative 0.01, 20 squared plus 0.4, 20 plus 1. If you simplify this one, you get 5, again meters, because this represents the height. So we can say the vertex has the coordinate 20 and 5. Now recall the meaning of x and y coordinates of the vertex. X represent the horizontal distance, which is this distance, and y represents the optimum value or the maximum height in this case. So we can say the maximum height is 5 meters. Now let's do the next question. The next question says, how far away from the quarterback is the maximum height reached? If you look at here, we said that x represent the x coordinate of the vertex represents the distance from the quarterback to the maximum height. So the answer to this part of the question is 20 meters. Now the next part of the problem says, what does the y-intercept represent in this case? The y-intercept, as we know, is when x is equal to 0. So if we set x equal to 0 in the original equation, what we are going to get is y is equal to 1. This means that the initial height of the ball when it was shot by the quarterback is 1 meter. This is the initial height when the ball was thrown in the air. Example number 2 is the following. You have a roof which is in the shape given by the following equation. Y equal negative 0.08 x squared plus 3.5, where y is the height of the roof in meters and x is the width of the roof from the center in meters. So if we draw, first of all, before I even try to draw it, the question is at what type of graph is it, linear, quadratic, or neither. You can look at the independent variable x. The maximum exponent, as you can see, is 2. So this is going to be a quadratic. Now, since we know it's quadratic, the next question says, is the graph opening upward or downward? By looking at the leading coefficient, you can see that it's negative, so it opens downward. So it looks something like this. Now, if we go back to the original equation, I just wanted to explain what exactly is x. It says x is the width of the roof from the center in meters. So if this is the center, x is the width which is here. So this is our x from the center. Now the next question says, does the graph have a maximum or minimum? Since the graph opens downward, this means that this point, the vertex, is a maximum. Now the next part of the question is, what is the maximum or minimum height of the roof? Again, since the equation is given in standard form, we are going to use the formula to find the x coordinate of the vertex, which is x is equal to minus b over 2a. So I'm going to say that x is equal to minus b over 2a. But b in this case, since we don't have any x term, is 0 over 2a, which is 2 times negative 0.08, which is going to be 0. So the x coordinate of the vertex is 0. Now to find the y coordinate, I'm going to substitute this back in the equation, and I'm going to get y is negative 0.08 0 squared plus 3.5, which is equal to 3.5 meters. This means the maximum height or optimum value of the equation is 3.5 meters. Now the next part of the question says what is the width of the entire roof? Again, let's just draw how the roof looks like. To find the width of the entire roof, we have to find the width from this point to this point. But to find this, we need the zeros or x-intercepts of the graph. To find the x-intercepts or zeros, we have to set y equal to 0 in the original equation. So we get negative 0.08 x squared plus 3.5 is equal to 0. We move 3.5 to the right. We get negative 0.08 x squared is equal to negative 3.5. Then we divide both by negative 0.08. And from here we get that x squared is equal to 43.75. We take the square root of both sides and we get x is equal to, remember when you take the square root of a positive number, you get plus or minus. So you get plus or minus 6.61. This means that this point is 6.61 and this point is negative 6.61. It is obvious to find the width, so we say the width is equal to 6.61 minus 6.61, which is 6.61 plus 6.61, which is going to be 13.22 meters. So this means that the width of the entire roof is 13.22 meters. The last part of the question says, if you have a support beam that must be placed across the roof 2 meters down from the highest point of the roof, how wide should the support beam be? So let's first draw the graph here and see what exactly this part wants. This is our roof, looks like this graph. Remember that this one, the highest point is 3.5 meters. Now I'm going to put a support beam here. This distance is 2 meters. I want to know what is this width here. To do that one, what I really need to know is the x-coordinate here and the x-coordinate here. And then as the previous problem, I'm going to subtract these two to find the width of the beam. But to find this x-coordinate, I have to find this y. And it's not that tough to find it, because I know that the whole maximum height is 3.5. When I come 2 meters down, the height that I'm looking for is 3.5 minus 2, which is 1.5 meters. So this is 1.5 meters. To find the x value when y is 1.5, I use the original equation, meaning I'm going to say negative 0.08 x squared plus 3.5 is equal to 1.5. Remember, this distance from here to here was 1.5. So I'm going to move 3.5 to the right. I get negative 0.08 x squared is equal to 1.5 minus 3.5, which is going to be negative 2. Now I'm going to divide both sides by negative 0.08, and I get x squared is equal to 25. When I take the square root of both sides, I get x is plus or minus 5. Now, as usual, if this is 5, this is negative 5, the width of the supporting beam is just 5 minus 5, which is 5 plus 5, which is 10 meters. So this means that the width of the supporting beam has to be 10 meters.